Welcome to our second video about data visualization using ggplot package. I welcome you again to subscribe to our YouTube channel and click the notification button for you to receive the notification whenever we upload a video. So we are going to use a data that comes with the tidyverse package. It's called MPG. It's called MPG data, that is miles per gallon data. Just looking at the consumption of fuel for this vehicle. And here we are looking at fuel economy data from 1999 to 2003 for 38 popular models of cars. It has quite a number of variables that are there. And before you start any analytics, you need to familiarize yourself with the data that you're using. And for that reason, I'm going to store it in an object called data, and I'm going to execute this section of the code. Once I've executed that, you'll see on our environment window, we have it there. I double click on it. See, we have our data that we just created. And this is the data that you're going to use. That's the data that you're going to use. And our first variable is the manufacturer. That is the name of the manufacturer. That is our first variable in that data set. Our second is the model of the vehicle. Model of the vehicle. Our third variable is engine displacement in liters. So just looking at the cc, this one is 1.8 cc, 1.8. The third entry is 2.0. Then Audi A4, we have 2.8 cc. Our fifth variable is number of cylinders, and you can see a good number of them. They have 4 cylinders, then there are a couple of 6 cylinders, and so on and so forth as we continue. The next variable is the type of transmission. Is it auto? Is it manual? Automatic? Is it manual? With 6 gears, 5 gears, and so forth and so on. The next one is the type of drivetrain, where we have the F stand for the front wheelers, R is the rear wheel drive, and 4 is the 4-wheel drive. The next variable is city miles per gallon, city miles per gallon, then highway miles per gallon. Then this is the fuel type that we are using. And lastly is the type of the car. So you look at, we have the compact, we have mid-size, and we'll see all those sizes when we'll be doing our data visualization. To start us off, we're going to start with our first graph will be a scatter plot. So we are going to use this scatter plot here. And points, whenever you are doing points, it's always about scatter plot. So we use points to see the distribution of our data. And here we just want to see, first we have our data, which is MPG. So you can define data equals to MPG, or just say data, you call the data by its name. Then plus sign is to say the next one. What are we doing? The geometry. And our geometry here, you see, we are drawing points. And now, after geometry, you define your aesthetics. So aesthetics here, we are saying that we want X equals to this engine displacement, and our Y equals to, we call this one highway miles per gallon. So when you execute this, remember the 3 mandatory components: the data, the geometry, and the aesthetics. Aesthetics is where we define our X and Y variables, plus colors if you want to add colors. The geometry now, you'll tell us what do you want to visualize, what do you want to map. Is it a scatter plot where you use points, or is it a histogram, is it a bar? So this is where you define. And lastly, the key thing is the data that you're using. So when you execute that, we'll have our output. You can see we have our output here. And on our y-axis, we have highway miles per gallon. And on our x-axis, we have the engine displacement in liters, engine displacement in liters. So this has given us this kind of a scatter plot. Now, what about if you want to add colors? If you want to add colors to this wonderful presentation, when you want to add colors, now the only thing that you need to define, and most of the time you'll find that when you're putting colors, now you point to categorical, variable, or factor variables. And for us here, the only addition inside aesthetics, we've said color equals to class. So we have the data, we have the geom, we have the aesthetics, which is x equals to displacement, and y equals to highway miles per gallon, and color additional, what we've added is color equals to class. So when you execute this chunk, you'll see that now our visualization has colors. And the colors here that we've added, you see now we have a legend, which has two-seater, compact, mid-size, minivan, pickup, subcompact, and SUVs. And they're represented with the different colors here. So here we can say from this, looking at this visualization, we can say, we can start to make some assumption about our data. And here we are seeing that displacement, engine displacement in liters is higher for the two-seaters vehicles. For the two-seaters vehicles, engine displacement is higher. What about highway miles per gallon is higher for a subcompact vehicle, and that's why you see we have a purple on top there. And most of the concentration is around this section here. So you see, and also we can deduce as engine displacement in liters increases, as engine displacement in liters increases, there's a decrease in highway miles per gallon. There's a decrease. You see, there's a negative correlation. There's a negative correlation between highway miles per gallon and engine displacement in liters. So that's some of the assumptions. But is that statistically significant? Is that statistically significant? So those are some of the tests that we'll be doing later on when we'll be doing inferential statistics. So we can also change the color of the legend so that instead of having different colors, you can have the same colors, but now we increase the sizes of the dots. We increase the sizes of the dots. How do you do that? You come to this chunk here, and you see here now, instead of saying colors equals to class, we've added sizes equals to class, then comma, color equals to blue. So this one will just give us blue color for all, but now the size will be different for different class. So when you execute this, you see now, when you execute that, you see that still it is more or less the same. SUVs have the highest highway miles per gallon, whereas the two-seater here, the two-seaters has highest engine displacement in liters, the two-seaters, and you can see it's at 7. So you see still the relationship is negative, but now what we've just removed is different colors. So you can even opt to have red. You can come here and say, you define the color that you want. You just say red. And when you execute that, the color will change to red. So it depends with the color that you want to use. So the sizes are here, and you can see the sizes they vary. But I would prefer if you don't change, use size equals to color, but you just use color equals to class. It is far much better than when you use a different. So here you can just say colors equals to class. Then you terminate it there. and you execute, and see, it will be more or less what we had visualized previously. It is more or less what we had visualized previously here. You can see here, see that equals colors, geom, highway miles per gallon, colors equals color, colors equals to class. So class shouldn't be, so colors equals to class. And when you execute that, you see now we have more or less the same graph. So that's how you visualize your ggplot. So what our next, we want to look at the bar graph, the bar graphs. So let's examine other objects that we can plot using ggplot, and here we will create a bar graph chart using the function geom bar. So we just add geom here, it was a point, now we've changed it to bar. So our first bar graph, look at our first bar graph, and it's just a simple bar graph, because what we've just said is the data, we are using MPG, the geom bar, and the aesthetics. And remember, for bar graphs, it should be our x-axis will have factor variables. And you see here we have factor variables, unless we are visualizing histogram that we are going to visualize in a few minutes, unless it's a histogram that will have quantitative, but all will be qualitative or factor variables. So here we just simple. What about if you want to, so it was counting the number of two-seaters, the number of compact, the number of the mid-size, minivan, pickup, subcompact, and SUVs. And from here we can say we have fewer two-seaters vehicles in our data set, whereas we have more two-seater, more SUV vehicles in our data set. So that's how you visualize that. Then what about if you want to add proportions? So instead of counting, you just want proportions. So we will say here, again, data, then geom bar as what we are visualizing, then aesthetics, then inside aesthetics, we'll say x equals to class, y equals to stats, in bracket proportion, then we group by 1. So when you execute that, you'll see now, instead of numbers, we are having proportion. So this can be up to 20% and so forth and so on. So these are proportion based on that we've, so you just replace, you say here y equals to stat in bracket proportion. So it can also count, because count is by default, but now for proportion you use that. Our next is histogram, and I mentioned that are valuable for understanding the underlying distribution of a data set, where we include the central measure of central tendency, the spread, and the shape. And here the common distribution, it can be skewed distribution, it is left skewed, right skewed, or it can be symmetrical. Then also there is multimodal distributions. So for you to draw a histogram, you must have your quantitative variable on your x-axis, then aesthetics, where you define your x-axis, then the geometry. Here our geometry is the histogram, because you want to visualize histogram, then the data. So when you execute that, you'll have a simple histogram. But this is not presentable, because you see, you need like to split, you need to add colors, you need to have titles to make it more appealing. And that's the beauty of ggplot. So here we are going to add some functions, like for example, we are going to add the bin width, make it a bit wider than what we have here. You see here, it's a bit thin, so we like it to be a bit wider. That is, we use the function bin width. We'll also like to add some colors in it, maybe red or blue or something like that. So we use the function fill to add some color. So let's do those two things using this here. And you see, we add everything inside aesthetics. So here we say ggplot, then the data plus the geom, the histogram that we're visualizing. Then on our aesthetics, we define our x, which is highway, miles per gallon. Then the bin width, the size of the bin, or the bars that we are creating. Then you are filling with navy blue color, and the outside we want it to be gold. So these you can change the fill color, the color that the outline color, you can change those on. So when you execute this, you see now we've increased the size of our bins to 3. Then we've filled our bars or our bin with blue. Then the outer line, it is gold. So we can change this outer line from gold to red, depending on what you like. So when you say, and then we can fill it with yellow. We can fill it with yellow. So when you execute that, you see now becoming more beautiful. And here you see that we've added now, we've filled, and then the lines, the outlines, just to separate all the bins. And you can see our model class is somewhere between 15 and 20. This is our model class. That is the class with the tallest bar, the class with the tallest bar. Then we can say it is skewed to the right because the tail is falling to the right. And we have some outliers that we're going to see later on when we'll be visualizing a box plot. So that's how you create histogram using ggplot. So the data, then the geom is the histogram, aesthetics, then x-axis, then you can increase the size of the bin. If that is too wide, you can say you want it to be 2, and you'll see the size is also reducing, or you can put it 1, and you see the size will all keep on reducing. So this is more like it. If you want to visualize the best, this is the best visualization that you can ever create in. But you can do so many things. You can add the titles, you can change the labels of the X, you can change the labels of your Y axis. So here we want to do a little bit, we're going to add other things. We've added the bin width, we've added the color, we fill the color, but we want also to do the scale continuous as well as the scale Y continuous. There are 3 function key will be fed into function break, then limits, and also expand. So for us, that will be easy. So this one, you'll get the script. I'll share with you the script after the class. So here you see we have ggplot, mpg plus the histogram, then aesthetics, x equals to that. Then bin width, we can reduce that bin width because I saw 1 was really nice. Then we are filling it with the color navy blue and also gold. Then we have this function here. It's called scale x continuous. So we want to say that the maximum value. So on your x axis, you want to have a breaks of 555. So your minimum value will be 0. Then your maximum value will be 45. And now it will be counting 5, 0, then 5, then 10, 15, 20 sequentially until 45 for the x-axis. So here you see, now when you come to scale y continuous, also we are saying breaks and count sequentially from 0 to 90. Then in between, we want a sequence of 10. So it's 0, 10, 20, 30, 40, 50, 60, 70, 80 until 90. So here is the limit. So we have the C 0 to 90. Then also it expands from 0 to 0. So when we execute this, you'll see that it has created the sequence. So this is our sequence, and you can see now this sequence is very high, and that's why it's important to know your maximum value and the minimum value that is in your variable. So you see here is 90. So we can reduce this sequence. We can reduce the sequence so that we have a bar that is making sense to us. So, and you can see here, more or less, our bars is up to 40. So we can say, let's say up to 40. let's use 50. Then also we would like a sequence of 5. A sequence of 5, then also here we reduce to 50. Then when you execute this section, at least this is more or less like it. This is more or less like it, but also still we can reduce it to 35. There's no harm. We can reduce it to 35. Then we come here also, we reduce it to 35. So when we execute, so that you don't have a bigger space at the top. Yes, now this is it. So this is more or less what we like to have, a sequence of 0 to 45. Then in between it is 0, we see 5, 10, 15, up to 45 for the x-axis. And then for the y-axis, we are starting from 0 to 35. Then we have in between is 0, 5, 15, 10, 15 to 35. So that's how you create the breaks between. Lastly, let's look at a box plot. So a box plot, also known as a box and a whisker plot, is a statistical visualization that provides a summary of distribution of a data set. It presents key statistics such as median, quartiles, and potential outliers in a concise manner. Here is a breakdown. So we have the first thing that we look at are the box. So the box represents the interquartile ranges, which is the range between the first quartile and the third quartile. And that is just the median. So the first quartile and the third quartile is called the interquartile range. Then the box is divided into two parts by a line, where the top part represents the portion between median and quartile 3. And the bottom part represents the portion between quartile 1 and the median. Then we have the whiskers. So whiskers, they extend from the box. So you have your box there, and you have the whisker that goes up from the box. Is often 1.5 times the interquartile range. Data point beyond the whiskers are considered potential outliers. They are potential outliers, and you're going to look at. Then the median is the line inside the box. So when you visualize that, you'll see the line inside the box is referred to as the median. That is the value, the middle value, the value at the center of your data. Then lastly, we have the outliers. So individual data points that fall beyond the whiskers are considered to be outliers. And for example, when you visualize this here, this graph here, the histogram here, you can see that we have some outliers, these outliers here. So these are what will appear after the whiskers, beyond the whiskers. Then also, and also these will be some outliers, because when you draw a normal curve, these will be outside. Anything that is outside the normal distribution curve, we consider those as outliers. Now, let's visualize and see all those parts. First of all, we say that we'll have the box. So the box, we have the box. Then there's a line inside the box. So this is the median, and it separates the upper quartile, the third quartile, and the first quartile. So this is Q2, the median. Then these are the whiskers. These lines here are the whiskers. You can see the lines there. So this is also the whiskers. Then the points that are outside the whiskers are called the outlier. For example, for compact, we have a number of outliers, 1, 2, 3. So these are the outliers. And here you can see, so this is how you visualize, and you just draw it. So I've stored it in an object called P, because I would like to use this P later on to show you something else. So here we say that P, create for me an object called P, and inside this object I want you to store a box plot for the class, and then the y-axis, our y-axis here is city miles per gallon. So you can change it even to be highway miles per gallon. Highway miles per gallon. When you change it, and you'll see your visualization will change. And you see SUVs has quite a number of outliers. SUVs have quite a number of outliers compared to other classes when highway miles per gallon. So that's how you visualize your plot. Then remember, Other components was the facet. How do you use the facet? So facet will be a standalone. Facet will be a standalone. So we have our box plot with our aesthetics equals to class, then y equals to city, then we fill inside using class, plus the facet wrap. So we want a number of grids to be created. We want to create a number of grids on our visualization, and when I execute it, you'll see that we have a number of grids. There's this grid 1 here, there's grid there's the 4th, the 5th, the 6th, and the 8th grids. So we've separated, you have quite a number of grids, and here you see that we have number of rows equals to 2, number of columns equals to 1. So if you want to change, you can even change, I want number of rows equals to 1, then you also change that, or you can let it be like that. So you restrict it on the number of rows that you want. Then when you execute it here, when you execute, you see it's returning an error because it's not making sense. So here you can have a 3 by 3 depending on the levels that are there. So depending on the levels that are there, you see now we have here, we have all of them are on that. So it can be how many rows we want to, these are 3 columns as we've specified. Then rows, a maximum can only be 2 rows. A maximum can be 2 rows. So that's how you specify. But now to make it even beautiful, we use a 2 by 2 table, and here you have, we have 2, so here and there, and that one. So these are the number of classes that are there. For example, our number of cylinders, we have 4, 5, 6, and 8 cylinders. But if you are using something different that is not even cylinder, maybe class, and also we know the level of classes that are there, then we'll be able to visualize it. Then our last is also, again, how do you add title? So when you add title, you use the function lab. You use the function lab, and here we come and say that lab in bracket title equals to cylinder by class, then fill cylinder. So when you execute it now, you'll see that we have it here, and then we have, so this is stacked bar graph. This is a stacked bar graph, and we have our title, which is these one, cylinders by class. Then we fill inside using the cylinder. So here fill equals to factors, then that equals to that. So that's how you visualize, you add your title. Then you can also stack, and again, this is you code flip, which is more or less what we've just positioned here, dodge. You can say dodge, position equals to dodge, and you see now it has splitted it. So it's no longer stack. So this function dodge, if we remove it, if we remove dodge, then our data, our presentation will not be stacked. So here the dodge makes it to unstack it. Remember, at the top we didn't have the dodge function, and that's why it was a stacked bar graph. But here we've added the dodge function, and it is position equals to dodge. Now it is not stacked bar graph. Lastly is we can alter the theme of our appearance by just adding the theme. X-axis equals tick, element line type equals to blank. So we don't want the line type, panel dot grid, then element. So we use all these. Then our title, we had the title here. We make it horizontal justification to be at the center. We also increase the size of the title, the text, the font size of the title. So when you execute that, you have our box plot here where we don't have the grids inside, And you see here we have our box. Our title is center line. If we remove this justification,